Alright, now let's go over a couple of more vocab words that we're going to need to continue on with the rest of our lesson. So next we have a system of linear equations, which is a set of two or more linear equations that must be solved at the same time. Then we have graphing, which is a method of solving a system of linear equations in which both lines are graphed. The solution to our system is then the point of intersection. And now we have two examples to go ahead and try out this method of solving our systems by graphing our equations here. So to do these, I think it's easiest if we convert all of our equations into slope-intercept form. Let's go ahead and do that for these two equations in our first example here, simply by solving for y. So my first equation, I've got y is equal to negative 3 over 2x plus 3. I'll do my second one in a different color. Now for my second one, I've got y is equal to 2x minus 4. So let's go ahead and just graph each of these. My first one, I've got an intercept of y is equal to 3 and a slope of negative 3, 2. And let's do one more point, down 3 over 2. Now I can make my line, but I've got a couple of reference points here. And let's see, for my second equation here, got an intercept of y is equal to negative 4, now slope of positive 2. Which we can see where they intersect right here is going to be 2, 0, which is our solution to this system. Now let's go ahead and try out our second example here. So for our first equation, let's rewrite that in our slope-intercept form again. And our second equation is already given to us in slope-intercept form, so I'm going to go ahead and leave that one alone. But now let's plot our two equations here. So starting off with an intercept of negative 1, and then we're going up 1 to the left 1 to give us that slope of negative 1. Gives us that downward slope of 1. Then for our second equation, we're starting at an intercept of 9, and then we can go down 1, backwards 1 to give us that positive slope of 4. And once we've got a couple of points in place, we can draw our line again. Then we can see this time around, we've got that intersection of negative 2, 1 for our solution for this system. So we've got two more examples here for our graphing examples. Why don't you go ahead and pause the video and see if you can work through numbers 3 and 4 by yourself, and then once you're ready, we can unpause and see if our graphs compare, or how they compare to one another. Alright, so go ahead and pause the video now and work through those. Okay, let's go over number 1 together. So in this first one, we've got our first equation with an intercept of y is equal to 4. Then we have a negative slope of 1 here. So I'm going to draw my points and then plot my line. Now for equation 2, we have a y-intercept of 2. And again, we have that negative 1 for our slope here. So as you can see, these two lines clearly don't intersect one another. The longer they continue on in either direction, they will stay continually spaced apart there. So this one, actually, we end up getting no solution here, which will happen every time we have parallel lines, which we can immediately see from these two equations having the same slope. Now for number 2, we already have our first equation here written in our slope-intercept form, so I'm just going to rewrite our second one here. Now that they're both there, I'm going to graph this first one with an intercept of y is equal to 3. And we have a positive slope of 4 here, so let's go down 4, backwards 1. That should be enough to give us our line. And our second one, we have an intercept of 3 again. So right there, this time a slope of positive 2, so we'd be going down 2 over 1, down 2 over 1, which will give us this for our line. Now, we can actually see we had the same intercepts in both equations, that positive 3, so we actually knew we were starting at the solution point right there, right off the beginning of our graphing here. So anytime we have the same y-intercept on these equations, we know our solution is just going to be that y-intercept. So these two were a little more tricky, but I'm glad you tried them out on your own. Now let's try out another checkpoint problem where we're seeing which graph represents a system of equations that has a solution of 3, -1. Well, if we have our solution already given to us, we just know we need to have the graph which intersects at 3, -1. So that means we're going to go ahead and look for that point on our graph. So we're going to be somewhere in the positive x direction of 3. So that eliminates this first one and this one. Moving on to C, we're moving into positive 3. And then we know our y coordinate here is -1. So just down 1 gives us that intersection here. I'd say C looks good to me, of 3, -1. Now let's check out our next method for solving systems of linear equations. We have one of our two algebraic methods, substitution. So in this case, we're just simply solving for one of our two variables and then substituting that variable back into our second equation. So I can see I already have a y by itself. So if I want to solve for y, I can very nice and easily subtract x from both sides to give me y is equal to -2x plus 9. Now that I've isolated this variable, I can substitute it back into our second equation here to give me an equation solely in terms of x. So I'm just plugging in my -2x plus 9 for my y, and then I'm going to subtract 2 more x and set that all equal to 11. So in this case, we have -6x plus 27 minus 2x is equal to 11. Combining my like terms for x, we get -8x here. And then let's subtract 27 from both sides to give us -8x is equal to -16, which if we divide both sides by -8, we get x is equal to 2. Now that we have x, well, we already isolated y in terms of x, so we can plug our 2 in for x here, give us y is equal to 2 times -2 plus 9, which is going to give us -4 plus 9, or y is equal to 5. So our final solution here is 2, 5. Which that's all we need to do when we're solving for our system with substitution. We'll just look for the point, same way we did on our graph. We looked for that point of intersection. It's the same right here. We just have our point for our solution. This time around, 2, 5. So now try out this next problem, see if you can use substitution on your own to get an answer for this new systems of equations. Once you're ready, just unpause and we'll go over it together. Okay, so for number 2, we already had y isolated by itself in our first equation here, so we can go ahead and just plug that in to our second equation. We're going to take 2 times that quantity, -5x, plus 8. And we're setting that all equal to our negative 2. So now we get 10x minus 10x plus 16 is equal to negative 2. So we can see we have an issue popping up right here where we have 0 with our 10x's and negative 10x's, they cancel, plus 16 is equal to negative 2, which says 16 is equal to negative 2. Well, is there ever a situation where we can say that 16 equals negative 2? Mathematically, no. So we know this is untrue, which means there is no solution where both of these equations will be true simultaneously. So for this equation, or systems of equation, we can say no solution here. So that would mean graphically, if we were to plot both of these lines, they would be parallel to one another. Now let's check out another checkpoint problem. We have a system of equations is shown with y is equal to 3x and x plus 2y is equal to 28. Determine whether the statements are true or false about the systems of equations shown. So letter A says, when using substitution to solve this system, the result of the first step should be 3x plus 2y is equal to 28. So this would be plugging in a 3x for our original x term, which that would show it's not properly substituted in. When substituting to solve the system, the result of the second step should be x plus 6x. Well, I could actually agree with that. For our first step, we could do plugging in our 3x for our y, which would give us 2 times 3x here. That would make our 6x. So I actually do like that equation, or like that second step there. I think that is a good second step. Then here it says the value of x is 4. Well, let's see. We know that x plus 6x is 28. So let's combine those and say 7x is 28. Now if we divide both sides by 7, we'll get x is equal to 4. So C is actually correct as well. Then D says the value of y is 4. Well, we know y is equal to 3x. So y is equal to 3 times 4, giving us y is equal to 12. So that's not true for letter D.